Hello everyone, today we're going to be solving a LeetCode coding challenge called Odd-Even Linked List. Given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. For example, you have a linked list with 5 nodes. This is the first node, second node, henceforth. And you want to rearrange them so that all of the odd nodes are together, followed by all of the even nodes. And the order doesn't matter. Okay, so this is going to be our function. You're going to receive a list node, which is the head of the list. And what can this parameter be? Well, if it's null, then there's nothing you can do to it, so just return it. Start with that. If head equals null, return head. What about if there's only one item? If head.next equals all null, can you do anything to it? No, it's already in the proper order. What if there's only 2 items? If head.next.next equals null, then the indices are already in the correct order, odds followed by evens, so just return it. So only if the list is 3 or more in length, you have to do anything to it. Problem. Well, your final answer is going to be all of the odds followed by all of the evens And how are you going to do this? As we always do with pointers. How many pointers are we going to need? Well, how many positions of interest in each cycle of the algorithm do we need to know? Let's think of the algorithm running in the middle of this list. So we're not near the beginning or we're not near the end. How many positions are we going to need? If you're in the middle, you're going to have your odds, followed by your evens, followed by another odd, followed by another even. So you're going to need to know where this odd is. Let's know with the pointer. O-N for odd and new. You're going to need to know where this even is. Another pointer. E-N, even new. We're going to need to know where to put this odd to. So we're going to need to know the current last element of the odds. Let's denote that with OE, odd end, another pointer. And you're going to need to add this to current last element of the evens. So let's denote that with EE, even end. And you might think, oh, we know that this even is always going to be just 2 ahead of the last even. So why do we even need this? In a linked list, you can only move forward. You can't move back unless it's a double linked list, but this is a single linked list. So it's good to keep track of this element because we're going to need it. But we do need one more pointer. We're going to need to know the start of the evens because we need to know where the last element of the odds is going to point to. So I did this problem with 5 pointers. You're welcome to try using less. But I wasn't able to unless I already know the length of the list, which is another method, but I think is less efficient than this method. So we already saw that we're only going to use this algorithm if you have at least 3 elements in the list. Alright. So if you have at least 3 elements in the list, what are these pointers going to be? Well, this is the head. The end, when you begin the end of the odd group, is going to be the first element. The end of the even group is going to be the second element. Also, the start of the even group is going to be the second element. And you really don't have anything for a new odd element and a new even element yet. But you do know that you have a new odd element. And that's going to be the element after the end, even end pointer. So even end dot next. This end denotes the next node of the even end node. And let's assume, since we're in the middle of this list, that you do have a 5th element. That's going to be the next even node. And so you assign that element to the even new. But of course, you have to be careful because you might not. So we have to take this into consideration when writing out our algorithm, which we will see later. But if you do these two changes, which is the first step in the algorithm, then you're gonna have your odd new pointer pointing to the third element and your even new pointer pointing to the fourth element. So what's the next step? Well, we have to point the current end of our odd group to the new odd element. And once we do that, we're going to have the third element after the first element. What's the next step? Well, you add the new even element to the current end of the even group. So you're going to have the second element pointing to the fourth element. And what do we do next? You have to point the end of the odd group to the beginning of the even group. And then you have your odds followed by your evens that you've seen so far. We haven't gotten to 5 yet. We don't even know if it's there. But so far, so good. And what's the last step in the algorithm? You have to set the end of your odd group to the newest odd element and the end of your even group to your newest even element. So let's do that. We can redraw it to look pretty. And now we begin the second cycle of our algorithm. What are we going to do? The same steps. You find the newest odd element and the newest even element. In this case, we don't have a new even element, so it's going to be null. But are we done? No, because the order is not correct. There's an odd element that's not together with the odd group, so let's keep going. Next step, you set a link of the end of the current odd group to the new odd element we found. And the next step in the algorithm was to add the newest even element to the current end of the even group. Well, this is going to be null, so when we do this, we actually erase this link that we don't want, because we want odds followed by evens, not evens followed by odds. And the next step in our algorithm was to connect the end of the odd group to the beginning of the even group. So now you already have our answer, and we can return this. But if you remember, there was a last step in our algorithm, which was to reset the pointers, which we don't need to do. So let's take this into account when writing our code. But there was one more thing we needed to check. What happens when we don't have a new even element? Well, when the length of the list is an odd number, you're always going to have an even element, so you don't have to worry about this. But what if the length of the list is an even number? Say it was just 1, 2, 3, 4. Then, as we approach our algorithm, following the steps, eventually you're going to run into an error in which you're not going to have an element after the current last even element to look for the new even node for, and you're going to throw an error. So we have to stop the algorithm before this, so we also take that into account when writing our code. So with all this knowledge we've gained, let's go write our code. We're going to declare a few pointers. We have our odd new pointer. That's going to start as head. We have our odd end pointer. That's also going to be head. We have our even start pointer. That's going to be head up next. We have our even end pointer. It's going to be head up next for now. And we have our even new pointer, which is also going to begin as head on next. So we're going to have a loop. We're never going to have a loop. Let's worry about the exit condition later. What's going to be our loop? Well, it's going to be our steps in our algorithm. So our steps in the algorithm are as follows. Your odd new pointer is going to become your even new dot next. Your even new pointer is going to point to even new dot next dot next. But as we've seen, even next at this point may be null, in which case this will throw an error. So let's check for that condition. If even new.next equals to null, then you break. And are you worried that if you break here, you're not going to complete the rearrangement of the list? Well, that's not a problem, because as we see in this algorithm, with a list of length that is an even number, if you break out of the loop before you get into any problems, it's already going to be ordered by odds followed by evens. So we're good. So going back to our algorithm, end.next is going to be odd new. Then this one, even end.next equals even new. This one, odd new.next is going to be even start. So as we saw, after this step, we may actually be done, right? Because 1, 3, 5, 2, 4 is actually our answer. So you don't even need to do this last resetting off the pointer step. So why don't we check here? Why don't we check here to see if we reach that? And the way you know if you've reached that is if you don't have a new even pointer, or rather if the new even pointer is pointing to null. So if even new equals null, you can break and you're happy. Lastly, reset the pointers odd n equals odd new, and even n is going to be even new. Lastly, you return the head. So lastly, we need to set a break condition. Well, in this case, we already took care of our breaks in the loop itself. The advantage to this is that you don't need to go over extraneous steps when you already have the answer that you want. So we can just set this to true. Now we go to LeetCode and code. Let's put the code we developed and see if it actually works. Accepted. Congratulations.